And okay, excellent. And I will go ahead and get started with introductions and welcomes so we can start right on time. And as our guests join via phone, we'll hear that that entrance. So welcome and thank you for joining us. My name's Kyla Esguerra. I am the Deputy Director of our Office of Undergraduate Research. And I have had the pleasure of working with our Senior Excellence in Research awardees for this academic year. And I really am thrilled to introduce each one to speak and to talk a little bit about the research that they've been able to engage with this past year. Um, just housekeeping items. Each of our speakers will have about 10 minutes to speak. And hello, Professor Lisdahl. Welcome. Thank you for joining. Each speaker will have 10 minutes, and then we'll do 5 minutes of Q&A. So please do think of a question or comment for the speakers, and we will have time for that in between. Hey, Mike. Um, So I think without further ado, I will introduce our first speaker. I'll introduce Jocelyn Jarvis, who will be talking about the work she has done in Professor Lisdahl's lab. And a huge thank you also to our mentors and to our judges who are here today. So thank you for coming and engaging in the symposium. And I will go ahead and turn it over to you, Jocelyn.
Hi everyone. I'm gonna start sharing my screen. All right, perfect.
Hey, that's JJ.
All right. So my name is Jocelyn Jarvis, and today I'm going to be presenting the associations between perceived neighborhood safety and objective neighborhood safety on behavioral inhibition among emerging adolescents. So first, there we go. What is behavioral inhibition? So behavioral inhibition is a temperament characterized in young children by heightened sensitivity to novelty, social withdrawal, and anxious behaviors. This can really be boiled down to a hesitancy to newness and new things. So some background information on these topics. So unsafe neighborhood perception may be a proxy of a disadvantaged environment and life condition with multiple risk factors that collectively contribute to subsequent deterioration of health. It has also been seen that parent perception of neighborhood safety are influenced by many factors, including actual crime levels in the neighborhood disadvantage, individual characteristics, and media coverage. And lastly, adolescents who perceive their neighborhood to be unsafe were 2 times more likely than those who perceive their neighborhood to be safe to report serious psychological distress, while adolescents who lived in areas objectively characterized by high levels of violent crimes were no more likely than their peers in safer areas to be distressed. So now to kind of talk about some of the theoretical framework that helped inform our work. So I will be describing the diathesis stress model, and as we can see on this flow chart, there's kind of 2 things that can make someone more vulnerable to develop a mental disorder, and this can be genetic disposition, or in this case, childhood trauma. And from this vulnerability, there's kind of 2 ways one can go. So if there's minimal stressful circumstances or situations in their life, there's lower probability of developing a mental disorder, whereas someone who had excessive stressful circumstances or situations may have higher probability of developing a mental disorder. So how this kind of goes into our study is that behavioral inhibited or disinhibited children who are already vulnerable to the development of psychopathology would be more susceptible to the negative effects of unsafe perceived environment. This in turn would cause there to be to have them at higher risk of developing future disorders. So, some reasoning for investigating this issue. So, children with a history of early behavioral inhibition show a higher prevalence of anxiety disorders, including social anxiety disorder, and at later ages. It has also been seen that structurally disadvantaged areas are associated with an increase in adolescent depression. So, the aim of our study. So, we aim to analyze the impact of self perceived neighborhood safety, parental perceived neighborhood safety, and objective neighborhood safety upon behavioral inhibition behaviors in emerging adolescents. The participants in this study. So we had 10,825 youth aged 9 to 10 and their accompanying parents and guardians. And they actually all participate in a larger study called the ABCD study, or the Adolescent Brain Cognitive Development Study. And so this is a national 21 site study. So this is a pretty big sample because it is national. And then I also included a chart here that kind of gives some more descriptives on what the participants, their demographics. So what measures did we use for this study? So we utilized self-report questionnaires on demographic information that the parents filled out. And they filled out things like gender, race, ethnicity, household income, parental education, and also like address information as well. Behavioral inhibition was assessed through the ABCD Youth Behavioral Inhibition / Behavioral Approach System scale. Perceived neighborhood safety was assessed by the ABCD Youth Neighborhood Safety / Crime Survey. And then lastly, we used residential crime history report through geocoded neighborhood information, and we accessed this through their address. Now on to our data analysis. So we utilized 3 general additive mixed model analyses for each mean variable. So one examined the effects of youth perceptions of neighborhood safety on behavioral inhibition. The second examined the effects of parental perception of neighborhood safety on behavioral inhibition. And then the third examined the effects of objective neighborhood safety on behavioral inhibition. And all 3 of these were performed while controlling for other demographic variables, such as household income or parental education, which could be a confounding variable in our results. Now on to our results. So general additive mixed models demonstrated significant association with behavioral inhibition scores across youth perception, the objective measure, and parental perception of neighborhood safety. Additionally, increased neighborhood safety was related to decreased behavioral inhibition, and these were only for the perceived neighborhood safety measures. So this would be self-perceived and also parental perceived. However, and this finding was really interesting, emerging adolescents who live in areas that reported more criminal activity had lessened behavioral inhibition, and those that lived in less crime areas had higher behavioral inhibition scores. So here are some of our results continued. So as we can see at the graph at the top, this is the youth report, and then the first graph at the bottom. Lower scores on the scales indicated that their perceived neighborhood was more unsafe, and higher scores mean that the neighborhood was perceived as more safe. You can see that the behavioral inhibition scores are higher for unsafe, and they consistently go down as it's perceived to be unsafe neighborhoods. And conversely, we can see in the crime statistic graph, where lower scores mean that there's less crime, higher scores mean that there's more crime. You can see that the behavioral inhibition scores actually decrease as you go down in this scale. So, implications of our study. Our results suggest that during pre-adolescence, self-perceived neighborhood safety is the greatest predictor of the association neighborhood safety has on behavioral inhibition. Results indicate that parental perceptions are not as salient as youth perceptions, yet they both are related to adolescent reports of social withdrawal and/or anxious behaviors. I do want to include some local implications. So locally, further examination on the protective factors of adolescents who showed lower behavioral inhibition in higher crime areas could aid in mitigating the effects of heightened behavioral inhibition for emerging adolescents in the greater Milwaukee area. I also did want to note that social support and communities and community connectedness are known to reduce crime in neighborhoods and have the best impact on reducing mental health concerns within the kids that live in these neighborhoods. So, some limitations of our study. So, the neighborhood safety scale was not very detailed, unfortunately, as this measure only consisted of 3 questions asked to the parent and 1 question asked to the child. Geocoded crime statistics are reported by police, and neighborhoods that can be more policed will thus have more likely to have an increase in reporting, which definitely calls into question how objective our objective measure of neighborhood safety actually is. Some future directions. So, longitudinal analysis should examine whether behavioral inhibition behaviors change over time and if there are any mental health conditions developed later in life. Further examination on the impacts of perceived neighborhood safety and the impacts this has on other aspects in the child's life. And also exploring differences in self perceived versus objective neighborhood safety as the youth get older. And I just want to include some acknowledgments at the end. I first want to thank Dr. Krista Lisdahl. She's been such an amazing mentor over these last 2 years of being in her lab and has just played such a pivotal role in my development as a researcher. I also want to thank Ryan Sullivan. He's been the best graduate student mentor over these past 2 years as well, and he's really helped me learn how to craft a project from start to finish. And he's always there to answer all the countless questions I've had during my experience. And then last but certainly not least, I want to thank the Office of Undergraduate Research, including Kyla and Jessica and Tamara, for giving me this opportunity to be a SERA student and helping with my funding over my undergraduate career. And they're always there to aid in supporting all of us through this journey of becoming researchers. And then here are my references and any questions. And then I'll stop screen sharing so I can see everyone again.
Thank you so much, Jocelyn. That was excellent. And we can do questions either via the hand raising function or in the chat, or you can also simply unmute to ask Jocelyn a question or to provide a comment.
Well, I'm going to jump in at the risk of I'm trying to understand all this fancy language, Jocelyn. Thank you for presenting this amazing work as usual. What are there any other variables that have been looked at as far as like having a link to behavioral inhibition that you know of?
Yeah, that's a really good question. What I had originally looked into, especially for parental perception, is I know that physical activity has a lot to do with behavioral inhibition. So kids that are usually more physically active have lower behavioral inhibition scores than kids that are more sedentary. That's kind of the first one that pops at the top of my head. But I definitely do think behavioral inhibition is kind of under researched as a whole. So I do think it's be a lot interesting to kind of research other variables that have an impact on this as well. Thank you for the question.
If I could piggyback on that, really nice job. Thanks for representing our lab so well as usual. Are there any variables that you'd like to explore more, and especially in relationship to some of these more community level or social level constructs that can actually impact individual development, or even whether or not genes get expressed through kind of epigenetic mechanisms?
Yeah, so I definitely think that I would love to kind of also look more into some of our measures that kind of see friendships and kind of social connections between kids. I think it could be really telling how well a kid is able to socialize with others or how maybe withdrawn they are, since that does heavily correlate with behavioral inhibition as well. So kind of looking at those factors of how outside of themselves they are with other people around them would be really interesting to look at as well. Thank you for your question, Dr. Lisdahl.
Other questions or comments? There is a question in the chat regarding the participants of the main study you discussed. How were participants recruited or chosen to participate?
Yeah, so our participants, we kind of recruited them all around Milwaukee, trying to get, a very good sample base from everyone from everywhere. So I know we recruited a lot in schools, and kind of community-wise, like a lot of community outreach. I wasn't a part of like the initial retention, but I know some people in our lab have been, but those I know were very main ways that we tried to recruit participants as well.
Thank you so much, Jocelyn. Amazing job. And we can give her some applause, even though we are in a virtual environment. Nicely done. I see
Thank
there's
you.
an applause. Yep, there's an applause emoji that can be used as well. So thank you so much. I'm going to go ahead and introduce our second presenter, Sophia Mattson, who will be presenting effects of differentially conditioned stimuli on working memory processes. Sophia, take it away.
Hello, yes, I am Sophia. I will pull up my presentation on my screen. Okay. So, thank you all for coming so very much. I am presenting effects of differentially conditioned stimuli on working memory processes. And so before we begin, I just want to let you guys know a little bit about what working memory is and how and when we use this process. So working memory is a cognitive process that allows us to actively maintain information over a brief period. And we use this process in plenty of everyday activities, whether it's studying, driving, grocery shopping, or listening to a presentation, perhaps. And research has found that enhanced attention increases working memory storage. So for instance, if there are plenty of distractions while you are studying, your working memory is going to be diverted and probably not be as effectively performing as if there weren't distractions in the room. And sometimes these distractions are emotionally salient. So, in fact, prior work has found that emotional stimuli preferentially captures attention, even if it is irrelevant to the task we are trying to focus on, right? So let's say you're studying and a bear comes into the room. It's going to be pretty distracting. It's going to take your attention away from your task at hand and disrupt your working memory processes for your task that you're supposed to be doing. And that is, that could go for a lot of different threatening stimuli that are inherently threatening, snakes, bears, you name it. Probably not going to happen while you're studying, but there are also acquired, learned, conditioned emotional responses to certain stimuli. And so that's kind of what we want to look at today. And a conditioned stimulus is created when a unconditioned stimulus of any sort, something you don't really have any affiliation towards, let's say an email notification. So let's say you are working on a paper and an email notification pops up on your screen. Maybe you don't think much of it. However, if every time an email notification pops up on the screen, you get shocked, you're going to start associating fear with this email notification, and it's going to start invoking anxiety. And eventually, even when a shock maybe is taken away every time email notifications appear, you're still going to be afraid every time an email notification pops up. And so we can be conditioned emotionally to a lot of different stimuli in our environment. And so this threat conditioned stimulus is what we call our conditioned stimulus plus, or CS plus. And on the other hand, conditioned stimulus doesn't always have to be threatening. It can also be safe. And so we can associate certain stimuli in our environment with a safe outcome. And this is not just something neutral to us, but something that lets us know specifically that this isn't going to hurt us, right? And so research has actually found that both aversive and safe conditioned stimuli can capture our attention preferentially and distract us from our tasks at hand. And so what we know about enhanced attention leading to greater working memory storage, and also what we know about how emotionally salient stimuli, whether aversive or safe stimuli, capture our attention, we can start to wonder how this might affect working memory. And there is a gap in the literature regarding how acquired threat or safe stimuli affect working memory. And so that is what I wanted to study. And how did we do this? Well, oh, this is strange, actually. There we go. First, we had our participants do a fear conditioning task. So we had 54 participants for this data that I'm going to show you. And our fear conditioning task consisted of rectangular stimuli. And first, our participants had to look at a fixation cross, and then a rectangular stimulus appeared, and it was in either one of two colors. So for example, in this example, our CS plus is purple. And once this stimulus shows up, we have them rate the shock likelihood from a scale of 1 to 5, 1 being not likely and 5 being very likely to shock them. And so after they rate the shock likelihood, the rectangle will remain on the screen for a short period of time for that 5,000 millisecond interval and then shock them at the very end. Now for our CS minus, our safe condition, the shock does not occur at the end of this presentation. And so eventually, after 8 trials for both the CS plus and CS minus, we hope to see our participants learn either a threat association to the purple rectangle and a safe association to the green rectangle in this case. And what we found was that they did learn it, of course. So people, by the end of their 8 trials for both CS minus and CS plus, our CS plus or aversive condition, people were rating it as a 5, very likely to shock them. And for our CS minus, a 1, not likely at all to shock them. So they did, in fact, learn the association. And we also had them do a anxiety rating for our CS plus, our CS minus, and also a novel neutral stimulus that we will introduce in our working memory task next. And so what we have here is that people did rate our CS plus has a higher anxiety level than our CS minus. And so in our next task, our working memory task, we introduced this neutral novel stimulus. And so here we have our CS plus, our CS minus, and our neutral stimulus in our array that's going to occur. And so we're not shocking them during the working memory task. We're just going to show them the colored rectangles that differ in orientation. So for example, we have them look at a cue for 200 milliseconds, followed by a fixation cross for a brief delay, followed by the array. And this is the target array that they want to pay attention to. So this is really brief, and they're only directed to pay attention to the orientation of these rectangles, not necessarily the color. So when the array goes away for a really brief 900 milliseconds and comes back, they have to indicate if any of the rectangles changed in orientation by pressing 1 for no change and 2 for change on their computer. And so what we want to really find out here is during this delay period when you are using your working memory, does it matter, let's say if the rectangle is green, purple, or red, how it's differentially conditioned and how it's going to affect your answer. Is it going to be accurate? Is it going to be slower when you have to indicate change or no change in the probe? So they repeat these trials for all the different conditions. And what we found, also after the working memory task, we have to recondition them after certain blocks to make sure that they maintain that fear to the CS plus and maintain that safe association as well. And we also asked them to rate the shock likelihood of this neutral stimulus in our working memory task. And so, as you can see in our post-conditioning shock likelihood graph, people rated the neutral as a 3, meaning they have no idea what this neutral stimulus is doing, if it's going to shock them or not. And our CS plus is rated as that 5. It's definitely going to shock them. We see our CS minus as that 1. And we also wanted to just look at accuracy for their working memory task. And what we found was that there wasn't a main effect for our condition, but there was a main effect for load. So in this task, there are either 2 rectangles or 4 rectangles. And so we have CS plus 2, CS plus 4, etc. And what that means is our main effect for load is that people had greater accuracy when there were less rectangles to respond to than more rectangles, which makes sense. And so we also looked at response time. And response time is interesting because we not only found a main effect for load, showing that our 4 target trials yielded longer response time than our 2 target trials, but we also found that the condition did have a main effect, finding that our aversive condition, our CS plus, yielded a longer response time than the CS minus. However, it did not necessarily yield a longer response time for our neutral stimulus. Finally, we looked at Pastor's K-scores, which is a behavioral indicator of working memory, and we did not find a main effect for condition, but again, we did find a main effect for load. And you can see as the 4 target trials have really high Pastor's K-scores, meaning when you have more items to look at and store in your working memory, you're going to be storing more items, so then a 2-item target. So what does this all mean? With our findings that the CS plus or aversive stimulus yielded greater anxiety scores than the CS minus and the neutral stimulus, we found that also that CS minus stimuli showed lower levels of anxiety than our neutral stimuli. So these effects remained throughout the working memory tasks as well. We also found with our CS plus stimuli that they did not impact working memory accuracy or storage compared to the CS minus and neutral stimulus. But however, we found that our CS plus or aversive stimulus does require more processing time than the CS minus and neutral stimulus. So while we did not find that it directly impacts working memory or not, we did find processing efficiency deficits for the threat-related stimuli specifically. And so this research is really important to understand how we function in like work environments and school environments when we're using our working memory the most. When there is a learned emotional stimulus that might distract us or affect how we work and how we do school, how we complete everyday tasks. And this research is really important for understanding how threat-related cognitive biases may affect us in our daily life. And yeah, I just want to take this time for any questions. I really want to thank the Office of Undergraduate Research for just being so supportive throughout the whole research process with funding and everything. Also, I want to thank all my family and friends for attending. And I would like to open it up for questions.
Thank you, Sophia. Wonderful job. Let's open the floor. Any questions or comments?
So nice job, Sophia. Beautiful job. I'm wondering, what would your advice be to people and kind of how to use these findings in their daily lives?
Right. So let's say, I guess with the past year, for example, for me, whenever I got a Twitter notification, I would really just start associating that with bad news. So whenever I do my homework, I try to keep my phone far away because sometimes notifications, especially ones that elicit anxiety, are going to be really distracting and might take you down a whole different tangent. It's going to make you lose your focus, and it's going to impact your working memory.
Great. So I'm hearing I should ignore my email.
Likely.
Really great advice, Sophia. Thank you.
Other questions? Question in the chat, how did you measure processing time? Did it influence their quality of work?
There we go, I unmuted. Yeah, so processing time, yeah, our response time was our main finding, our significant finding. What we did really was just, there's an automatic timer along with our task. So every time they indicated 1 for change or 2 for no change, it recorded how long it took them to decide whether the orientation of the rectangles changed or not in the task.
Thank you. Any other questions for Sophia? Thank you so much, Sophia. Incredible work. We give you our applause. I love how many people found the little clapping hands too. It's fun to see those along the bottom. Very good. So we will move to our next. Oh, it looks like Bill has a question. Do you have a question, Bill?
The thought in my mind is how long does these memories last? Do you have to keep refreshing them? And as you grow closer to 80, why are they gone?
Right, so this is just working memory. So this helps you actively maintain information, like when you are taking or when you're studying and you're trying to memorize something really quick, you have to constantly use your working memory to kind of like, let's say, look at a fact, look away, what did I just think about, and recall it. It's a really quick process. So this is different from long-term memory. Does that make sense, Grandpa?
I love the support. Thank you for attending and asking a question.
Thank you for making it available to us.
Of course.
Is that your actual grandfather?
Yep.
Oh, I just love that. I love it when families join in. So thank
Yeah,
you.
we're all here.
Thank you all for being here. We'll give Sophia one more round of applause and then I'll ask Louis to come on screen. Great job, Sophia. So our next presenter today is Louis Chapman, who will be presenting modified material for removal of ammonia from water.
Were you here? Or?
Hey everybody, can you all hear me?
Yes, we can.
Okay, excellent. Let me just start this from the top. Okay, so I've divided this presentation into 3 different parts. I'm just going to dive into the first part. This is all about my research, what I'm doing. Like Kyla mentioned, I'm working on removing ammonia from water. So just an introduction here. Ammonia is a common source of nitrogen in rivers and in lakes. This can be problematic because it leads to expedited eutrophication, which is the proliferation of algae due to nutrient overload from things like phosphorus and nitrogen. This production of algal blooms consumes too much of the ecosystem's oxygen and can be the cause of damage to the health of these ecosystems. Not only do they consume oxygen while they're alive, they also consume oxygen while they're decomposing. So it's kind of like a double-edged sword in a way. So where is it coming from, you might ask? Well, it's kind of everywhere, unfortunately. One source of ammonia is pet waste. So when people don't pick up after their dogs, it will usually end up polluting a lake or river. The good news is that most of the polluted runoff will be generated in a really small area known as a point source. Agricultural sites or wastewater treatment plants are common examples of point sources. So what are we doing to fix it? Well, there's a few ways that we can go about fixing. One really common way is called nitrification. And this is something that uses a bacteria called Nitrous amonas. And these bacteria don't consume ammonia when the temperature drops below freezing. Additionally, it's not a super simple process either. It's kind of expensive. So as you can see from the diagram there, but really these limitations are necessitating the development of a new filtration mechanism. And so that's where we get to my abstract. My project intends to develop a material for removal of ammonia at point sources. It can be engineered to accept ammonia over other pollutants, which would make it a good choice for use in waters with multiple contaminants. Unlike nitrification, this method may be implemented in cooler climates, and the study involves optimizing the absorption kinetics and ultimately ensuring its suitability for environmental applications. Okay, so the methods that we're using here are called ion exchange, and in particular, we're using a cation acceptor for molecules like ammonia. A really important property of ion exchange is that it is reversible, or exhausted exchange material may be restored to the original state and used again. So a few little details that I can tell you about my project, even though there are some patent disclosure information concerns. The chosen cation acceptor, our filter, really, it occurs naturally and is cheap to procure, and it can be modified to improve performance. The modification that we're doing does not incur any prohibitive cost and just involves 2 steps, cleaning the particle and then impregnating with a metal precursor at high temperature. So the way that we know whether or not this is working is we'll challenge the modified filter with an ammonia solution of known concentration and compare it to the performance of an unmodified material. This involves finding the amounts of ammonia absorbed in both static and dynamic conditions. Static condition would be something like a 12-hour long experiment, and then a dynamic condition would be something at a constant flow rate for something close to like 3 hours. So after we regenerate the filter, we'll challenge it once more just to ensure that it's not seeing some sort of decrease in the performance. And then we'll also deploy it at a point source in the field and make sure that it's not seeing a decrease in performance there either. So here's just a little bit of my results. I know this is probably like a big jumble, but really what you're looking at is just a bunch of different modifications that I've attempted, as well as the unmodified material. Really, the unmodified material is pretty well in the middle here. Our results are indicating a pretty modest increase of about 5% in removal percentages for some of these batches. Other studies that have even been carried out in the Silva lab for contaminants like phosphorus have seen increases of up to 15 to 20%. So this can certainly be improved. But an important thing to note here is that the study is really proving applicability rather than concept. We know that there are modifications out there that work. What we want to prove is that it works for the particular source of material that we've chosen. That is really the biggest idea we're trying to prove. So one significant thing that I've helped contribute to is the development of our lab's ammonia detection method. This is really important because, like I said, every summer we have to test whether or not the material is working in the field. So we'll go to a farm nearby and make sure that we're seeing the levels of removal that we need to see. I think that concludes just like my research part. Now I'd like to talk just a little bit about undergraduate research at UWM because I had such a good experience doing it. Really, it's just a boatload of opportunities from these like abstract and poster preparation workshops to community outreach opportunities, which is where I got that awesome picture from my second slide, to updates on all sorts of scholarship and funding and mentor-student matching. All of these things, I think, I made the joke in our rehearsal last week. It's like, I wouldn't be all that surprised to see the common cold, the cure for the common cold come out of undergraduate research at UWM. It really is an awesome program. There you'll see also conferences. They like send students to both local and regional and national conferences to present. I've presented at all of these conferences. This is my 3rd year presenting at these 3. And it is an awesome opportunity to share your research with your peers. And then specific acknowledgements, just to get into a little bit more. At the Office of Undergraduate Research, I'd really like to thank Kyla Esquera. She proved to be like a really valuable mentor to me the last year, doing all these, helping me with like guidance on abstracts and posters, conferences, scholarships, just navigating my senior year. And then also Jessica Schuld, who was another awesome mentor, and chaperoned NCUR 2019, which was an awesome experience for everyone involved. People behind the scenes at the Office of Undergraduate Research too. I know they're putting in a lot of hard work. But moving on, my coworkers, definitely some people I'd like to thank. I constantly had to rely on other people's understandings, and I still do. In particular, I would really like to thank Alice Leachis, who was effectively the grad student on this project. It definitely was not on her list of official responsibilities, but she always treated me like it was when I had questions for her. It was like more than one occasion where her input really helped to advance the project from a state that it was in. So I hope that one day I would be able to serve as a mentor to someone as she has for me. And then, of course, obviously, my PI, Dr. Silva, has been truly invaluable to me as a personal and professional mentor. I think she does an amazing job of preparing students for life after college. It's really evident to me, having seen so many of my coworkers move on to exciting and unique opportunities because of their diligence and professionalism that Dr. Silva helps to develop. And just comparing that, seeing that with how much I struggled my first few months in the labs. So that has really been big for me. A lot of these lessons have helped me to feel confident in my ability to understand expectations and communicate effectively with my boss. I expect that I would use a lot of these skills for my entire professional career, and I'm really thankful to Dr. Silva for sharing them with me. That pretty much wraps up what I wanted to say. This is just like a conclusion statement here. I look up to a lot of people that I met through SERF and SERA, and I'm thankful to the Office of Undergraduate Research really and the entire Silva Lab, obviously, for providing me with all of these unique opportunities and experiences. And with that, I'd like to open up the floor to questions, if anyone has any.
Thank you so much, Louis, for your kind words, your excellent research, and you truly have been a great ambassador for us. Just a note for the audience too, our Senior Excellence in Research awardees do serve as ambassadors for undergraduate research on campus. And as you can see in our presentation so far, they truly represent the university in amazing ways. So thank you, Louis, and thank you to all the SERA recipients for representing us so wonderfully. So let's open it up for questions or comments for Louis, either about his research or about his undergraduate research experience. And let me open up chat here. I'm happy to read questions in chat, or raise hand, or simply unmute. I can start with the question, and hopefully our group will come up with one as well. But Louis, at the Global Water Technology Accelerator, you have access to work with so much cutting edge equipment. You're really seeing kind of a interesting facet of the water industry there where you're working. Can you say a little bit about that exposure and what that's been like, and maybe your favorite part about working at that facility?
Yeah, definitely. It is a lot. It is so much to learn. In particular, using like a lot of the equipments I think you're talking about requires so much specialized knowledge. That is really where like having coworkers that you can rely on for information and their expertise comes in so handy. One thing that that I have experienced personally is needing to go down to the School of Freshwater Science, which is about a mile away from where I work, just to talk to people who have this experience and have detected ammonia in water before, because it's not something that is super common necessarily, or that you can just like look it up on the internet, like, oh, what's the easiest way to do this? It's like a lot of times you need to know, or you need to talk to someone and they'll tell you all the specifics of what you may be doing wrong. So I'm also thankful to have that resource too in the community. They are super knowledgeable over there.
And are you hoping to stay within the water industry as you move on after graduation?
Absolutely. I was joking that that picture that was on my second slide, just outside the window there, is like a whole area that like several acres that they're developing into a water technology center for Milwaukee. So there will definitely be jobs to be had in the area, and lots of opportunities, and cool people that already work here and do study things that I am interested in.
And I see Bill has his hand up. Bill, please.
I just wonder if this technology is going to be used. I think it's mostly in the South with the mega chicken farms and pig farms, where the groundwater is being polluted. And the second question I had is what percentage of ammonia is tolerable or is not toxic to humans?
That's a really good, your second question is really good. I think it's like 2 milligrams per liter. I don't want to misquote you on that though. Don't take my word for it. Don't go drinking ammonia water. That's under 2 milligrams per liter. With regards to your first question, I know that that would certainly be plausible. I do have suspicion about, you said mega chicken farm, and I immediately am thinking like, oh God, that's like an environmental disaster that you're talking about. That this material would be really good for like a small farm or maybe even a medium-sized farm, but not a big chicken farm. You would want a more intense, something like the nitrification technology that I showed you. A bacteria consuming ammonia will do it at a percentage of like 97 or 98% or even 99% removal, whereas the technology I use doesn't typically achieve those rates. It will achieve about 90% when it's done really well.
Thank you.
Thanks, Louis. Are there other questions or comments? Okay, thank you so much for your work, your ambassadorship. I appreciate it. We do have a short break right now. Our next presenter will start at 2, so we have a little bit of time to stretch legs. I'm going to just put up a screen that shares the schedule, but at 2 o'clock we'll have Ismael and Devan presenting their work from their materials science and engineering lab. So quick break, and please do come back a few minutes before 2. Good afternoon, everyone. Ismael and Devan, if you'd like to get set up, we'll make sure that we can see your screen, and we will get started again at 2 o'clock. Hello.
Hi. Oh, there we go. Sorry, my mic was off there for a second.
You're all good. Welcome.
Try and turn my volume. There we go. And let me share my screen with you really quick. Alrighty, and you see what I see?
Yep. Looks great. You're at your bibliography though. There you go. Perfect.
Say that
Okay.
like I was gonna like this or how?
So we'll get started in just a few minutes, audience. And just really quickly, you know, we are definitely making the best of our current situation with having our virtual colloquium here. And thank you for joining us and being an audience here for us. we certainly wish we could celebrate these individuals on campus with our Senior Excellence in Research Colloquium. In the past, we've enjoyed having some refreshments and some snacks and some beverages to celebrate the year of hard work that these students have accomplished. So we are doing the best we can with our current circumstances, but students, please know that we are celebrating you and your accomplishments.
Are we going to be able to screen? Are you all ready?
Let's give it another minute, just in case we have individuals joining us right at 2:40. So just another moment.
Okay.
And then I'll go ahead and introduce you. Okay, since we have 1:59, I will go ahead and begin to introduce my next speakers. We have Ismael Ramirez and Devan Siegfried from Benjamin Church's Material Science and Engineering Lab, and they will be presenting performance of alumina forming alloys in decoking atmospheres. So thank you for being here and take it away.
All right. Hi there. My name is Devan Siegfried, and with me is Ismael Coello. There we go. This is a brief overview of our project. We're going to be going through the introduction, the methodology, and our results from our project.
So many of the plastics that you and I use every day are made of polyethylene. And polyethylene, the basic building block is ethylene. And these are made in these huge factories that turn these long molecules into short ethylene molecules and carbon. This occurs in these stainless steel tubes. And what stainless steel tubes are made out of is you have your matrix or base material. Then you have a protective layer, this protective oxide layer. And what does it protect it from? It wants to protect it from the carbon buildup that we mentioned in the middle there. And this carbon buildup is actually really bad for the efficiency of this process, because as carbon builds up, you need to clean it off. And if you can imagine, in a billion-dollar plastic industry, this is going to take a lot of time, a lot of effort, and of course, a lot of money. And so what we want to see in our research is what type of stainless steel will work better to inhibit this coke formation. We're going to be looking at two different types of stainless steel. Typical CFA, chromia forming alloy, and then a newer modern aluminum-based stainless steel, alumina forming alloy, or AFA. And what we're going to do is we're going to take these, coke them, and then get rid of the coke, which is called decoking.
That leads into our methodology. We're going to start off with our original samples that we have from industry as received. And then we're going to pre-oxidate them or have the protective layer that's going to be put on it via implementation of an atmosphere. Afterwards, we're going to coke them or put them in the other atmosphere where carbon is going to be attached to it. And then finally, we're going to decoke or remove the carbon, and that's going to be at the varying atmospheres.
And so what this graph is telling us is the mass changes after we cleaned the coke off of the parts. And so let's talk a little bit about the low PO2, moderate PO2, and high PO2. What does this mean? And so What we theorize is that oxygen combines with carbon to make a gas, which will then escape, meaning that we will have gotten rid of the coke. And so a low partial pressure of oxygen is going to remove some coke, and then a moderate amount of partial pressure of oxygen will remove a little bit more coke than the low PO2, and then the high partial pressure of oxygen will remove the most amount of coke. And that's something that we found with this graph. We see that more oxygen is going to be a more aggressive clean, getting rid of that carbon buildup. Another thing that we see if we focus on just the blue circle and the green diamond is that AFA, the more modern material, is better than the typical material because it lost weight instead of gained weight. And we're going to talk about why this happens in the next few slides. First of all, we wanted to look at what the material looked like. So what we did is we grabbed our samples, we cut them in half, put them face down, we mounted them, and then we polished them. And what it leaves us seeing is the structure from the surface all the way to the base. And what these pictures allow us to see is if we in fact have the structures that we want to see, such as the layer of coke or the protective oxide layer that protects the base material. Unfortunately, if you look at the picture on the left and the picture on the right, it doesn't seem to be much different. And so we have to go through other methods to look at our problem in a different perspective.
The other methods mentioned earlier are going to be the microscopy and microhardness. As you can see on the left, there is a graph that is going to be our hardness versus how deep we are in the material. And to the right is going to be a microscopy of our sample itself. As you can see in the region above, there is going to be a carburized layer. That's going to be the darker region. And then on the graph to the left is going to be the showing of how deep we are. So the region that's higher in the hardness is going to be correlated with the darker region. And the region that is going to be lower in hardness is going to be the region that is going to be the base metal. This transition in hardness is what we're trying to avoid because this means that there is going to be a presence of the chromia carbides. This differs in the alumina forming alloy or the more modern version because the hardness is going to be consistent, meaning that there is no variation in composition. This is depicted on the picture to the right. You can see that there's no dark region that was displayed in the previous picture. This is what we are actually after. This means that there's no interaction from the carbon with the actual base metal, which is good.
And I know this graph might look intimidating or tedious to try to understand, but I'm going to try to explain to you the main takeaways from this. So what is X-ray diffraction? It's basically you throw an X-ray at a part, it interacts with the part, and then it bounces off. And so that interaction and the bounce is measured. And the X-ray will touch a specific structure and say, oh, this is this. And so every time it does that, it kind of gives us a tally. So the higher peaks means that there's more presence of that specific structure. And then we actually have the specific structures that we're talking about. And so in this picture, we can see that we have something called CR7C3, which is a type of carbide that might not be what we are looking for in the material, because this means that the carbon that the oxide layer is not protecting against the carbon and is allowing the carbon to get into the material and combining with other things inside of the material to make these two different structures.
So the conclusion that we drew from this is that the AFA overall had a better performance. It did not have any mass gain. It didn't have a variation in hardness in its depth, and it also had a no carburization that was as easily detectable as was in the CFA, which is going to be our traditional ones. That one carburized more, it had a transition in mass, and it also had a transition in the hardness with the depth inside of the metal. We also took another takeaway that the higher the partial pressure of oxygen is going to be more aggressive in atmosphere.
We'd really like to thank you for your time, for the time that you're taking to see these presentations. It really means a lot to the presenters and to the students, to the university. And we'd also like to thank our PI, Dr. Ben Church, and Liz, who we work under, and the Office of Undergraduate Research for giving us the opportunity to learn all of these new tools and new techniques to do our research. And at this point, if you guys have any questions, we would love to answer them.
Thank you, Devan and Ismael. Excellent work. Questions or comments for the group, from the group? There's support in the chat. Great presentation.
Thank you. Thank you.
Thank you.
Way to represent material science and engineering. I'm guessing that's what that stands for.
Yeah.
Yes.
Question from Liz. Are there any implications or ideas you have for future research on this topic?
Sure. There is mention of possibly looking at variation of different atmospheres and also looking at the efficiency of those different atmospheres. So instead of having it be a hydrogen and ethylene atmosphere, it would be a change in atmosphere to other possible petrochemicals that could be shown. Any other questions?
We'll take any questions.
I have a question. How did you get into kind of researching this topic? Like, what kind of started the process of going into this research?
Yeah, so one of my goals was to learn more equipment and learn more about like the opportunities here at UWM. And so this project is very heavy on equipment use. Like we use like microscopes, we use the X-ray machines, we use different types of etchants so we can see the structures that we saw. And so it was really a project that allowed me a lot of opportunities to learn about a variety of things.
Ismael, do you have a favorite technique or equipment that you have learned?
Oh yeah, hands down SEM. The very, very up close microscope. It's just really impressive to see what you can see in the structures that you can't see with your naked eye.
Other questions or comments?
We promise we're friendly.
Okay, how will you apply this to your future goals?
I actually am applying this currently. I had a struggle between wanting to either start up in industry or go to graduate school. And this actually helped me decide what I wanted to do, which was further education. So this definitely applied heavily to me because I wanted to actually further this research as well. So that's how it applied to me.
Can you talk about what's next for you then as far as your education?
Yeah, I am trying to get a master's here at UWM. I applied to the program and I'm actually in the master's / bachelor's like accelerated program. So I started up on some grad classes and that's going pretty well so far. And then in the fall, I'm gonna try and continue that.
Excellent. How about you, Ismael?
Yeah, so the next step in my career, I'm going to go for a PhD at Northwestern University starting in the fall.
And will you be, what kind of research questions will you be looking at? Do you have a sense at this
Yeah,
point?
I think it's going to be something to do with additive manufacturing of high entropy alloys, which is just instead of steel being like mainly iron, it's like equal mixes of different elements.
And why is that important to look at?
Right. It's very important to look at, especially like looking into the future, because right now things are made one way, and because of the way that they're made, there's a lot of constraints on what you can do with the material. But with additive manufacturing, you really have a lot of flexibility to build the material how you really want it to and achieve properties that might not be as easy or have been impossible with other methods.
Excellent. Well, congratulations to both of you and well done. Thank you so much for your time and your work.
No, thank you, and thank everybody.
Okay, we can get our next presenter set up and ready to go. Next will be Anna Kaminski, who will be presenting her atmospheric science research entitled A Modern Three-Year Climatology of North Atlantic and Western North Pacific Extratropical Cyclones. And take your time getting ready.
Okay, can you hear me?
Yes, I can hear you. We can't see your screen right now, though.
Okay, I was having difficulty unmuting myself, so.
Okay, yep, I can hear you. And we can see your slides.
All right, so my name is.
Oh, there we go.
Good?
Yep, we're good.
Okay. All right, so my name is Anna Kaminski, and I am working with Dr. Clark Evans in the Atmospheric Science program. We have a little bit of a tweak to the title, but it's the same project. Preliminary development of an objective method to classify tropical cyclones by satellite imagery. So we're going to start by establishing the difference between tropical and extratropical cyclones. So a tropical cyclone image is here on the left. This is Hurricane Florence. And you can see that this structure is generally symmetric in shape. Tropical cyclones typically develop in the lower latitudes near the equator, and they also develop due to the energy released from the warm ocean. And tropical cyclones tend to have a warm core, meaning that the core of the low pressure system is warmer than its environment. Moving on to the extratropical cyclones, we can see that the extratropical cyclone pictured here is definitely asymmetric in shape. We see the elongated frontal boundaries, and mid-latitude or extratropical cyclones are typically developed in the mid-latitudes. They are associated with the weather systems that we see here in Wisconsin. And extratropical cyclones are associated with a cold core system. So the core of the low pressure system is colder than its environment. And we are mainly focused on the transition from a tropical cyclone to an extratropical cyclone called extratropical transition, or ET. There have been mainly two studies or methodologies done on this, and one is using satellite imagery. The top panel here shows Super Typhoon Violent in 96, and the bottom shows Typhoon Opal in 97. The first column here shows the first time frame of the typhoon. We can see the general symmetric shape of the tropical cyclone. Then moving on to the next panel of images in the middle, we can see that it's starting to lose its symmetric shape, and it's starting to develop some frontal boundaries as well. And then looking at the last panel, it's starting to erode away completely with a decrease in cloud coverage and some possible more frontal development. So this is one good methodology because we can visually see the satellite imagery associated with the cyclone. However, extratropical transition is a continuous process. It doesn't happen instantaneously, and there's not one point where it starts and ends. There is a start time and an end time, and this methodology is very subjective. Different scientists may disagree on the start time and end time of this process. So there's another methodology called the cyclone phase space, or the CPS, and this is a more objective methodology. This methodology focuses on the thermal structure, or the core temperature of the cyclone, and it also focuses on the system symmetry as well. So this image up in the upper right here shows the timeline of the cyclone, A representing the beginning and Z representing the end of the cyclone. The cyclone originally starts as a symmetric warm core, and then as it transitions throughout its lifetime, it ultimately ends as an asymmetric cold core system. This is a typical process, or a typical timeline of extratropical transition. We want to see it from a symmetric warm core, turning asymmetric, and then ultimately becoming an asymmetric cold core. However, not all cyclones go through that specific process. This example shows the cyclone starting off as a borderline symmetric warm cold core system. And then as it progresses, it turns into an asymmetric cold core, which is the complete opposite of what we would expect as it moves further north. And then toward the end of its timeline, turns into an asymmetric warm core, and then ultimately at the end of its timeline, it turns into an asymmetric cold core. So this methodology is useful because we can have an objective way to identify whether it's a warm core or cold core structure, in addition to using the symmetry. However, as we see in this example, not all cyclones follow this exact pathway. So these two methodologies give us motivation to find a way to utilize both the core temperature and the satellite imagery. So our methodology, we utilized a software called Tempest Extremes, and we inserted ERA5 reanalysis data to automatically track tropical and extratropical cyclones in the North Atlantic, East and West Pacific Ocean. We specifically looked at the months of June through November because tropical cyclones are most common during that time. We looked for cyclone tracks based off of a localized minimum in sea level pressure that also had a 2 millibar difference with its surrounding environment. In addition, we also added a terrain height criteria to exclude low pressure minimums from terrain height. When you have regions of high terrain and it gets heated, that tends to create localized areas of low pressure, and they are not always associated with extratropical cyclones. So we wanted to exclude those tracks. And then lastly, to separate the warm and cold core cyclones, we added a temperature criteria aloft in the atmosphere that was 0.4 Kelvin degrees warmer than its environment for warm cyclones. And we also required that criteria was not present for cold core cyclones. So then the ERA5 reanalysis data was used to make sure that that software was tracking the observed tropical cyclones, or what actually happened. This image here shows the tropical cyclones that actually occurred and what was observed in 2017, 18, and 19. We see tropical cyclones in each of the ocean basins. And then this is a zoomed in image of specifically the East Pacific and the North Atlantic Ocean with the warm core cyclone tracks overlaid on it. So this was the warm core cyclones that were tracked by our program with the specific criteria that we had. We see a lot of overlapment with the red and the black tracks, and that's what we want to see. That's a good thing. We want to see that our program is tracking the cyclones that actually occurred. However, there are some instances, for example, Tropical Storm Brett, that were not identified by our program. And I will explain a potential reason why Tropical Storm Brett, in addition to the rest of the tracks that were not identified, a reason why it wasn't tracked. So this is an image of sea level pressure on the first day that Tropical Storm Brett was observed. We have a general area of low pressure here, a general area of high pressure, and this is the region where Tropical Storm Brett was observed just north of South America. As we move further in time, your areas of low and high pressure stay generally in the same area, and Tropical Storm Brett continues to move to the northwest. And then on the last day that it was observed, we see that it is generally still north of South America here, but we see that there is a general and consistent area of pressure around 1012 to 1014 millibars. And one of the reasons we think potentially why Tropical Storm Brett was not identified is because there is such a small pressure difference in this region. The pressure difference within this small area was not strong enough to be identified by our program. So eventually we want to be able to track a majority of the observed cyclones. However, because this storm and some of the other storms that were not tracked, because they were not strong enough, they may not be able to be fully tracked. So for our future work, we want to repeat this process for cold core cyclones, and then we are going to train a machine learning algorithm to learn the difference between tropical and extratropical cyclones. So basically, we are going to give this model enough information of sea level pressure data and satellite imagery and say this sea level pressure and this satellite imagery is associated with a tropical cyclone or an extratropical cyclone. And then eventually this model will be able to do it by itself and automatically know when it sees a satellite imagery if it's associated with a tropical or extratropical cyclone. And then once this is developed, we would like to test this algorithm during future hurricane seasons to see how accurate it is, and then hopefully implement this method into the National Hurricane Center forecast practices. But this project will ultimately lead us to a better understanding of extratropical transition and a better way to classify and evaluate extratropical transition in the future. So I'd be happy to take any questions, and thank you all for attending and listening.
Thank you, Anna. Excellent work. Questions or comments for Anna?
Well, first of all, lovely presentation. Enjoyed that very much. And how will this help inform, let's say, in hurricane predictions and in terms of whether they follow the course that you're predicting or not? How do you imagine? I know it's kind of a bit farther down the road where you're going to get to that point, but how do you imagine that working?
Sure. So when a tropical storm transforms into an extratropical cyclone, they have different, I guess, consequences, for lack of better words, how they affect different areas. So when we are able to identify whether the storm is tropical or extratropical, we'll be able to identify kind of the impacts of the cyclone. And then ultimately, the extratropical transition process can be important into how often it occurs or why it happens, because like I stated, not all of the cyclones go through it, and they also have a different pathway. So mainly just to see how it impacts other areas, as well as learning a little bit more about this transition process.
All right. Well, thanks so much.
Yes, thank you.
And Anna, there's a question in the chat. Can the satellite identification method be blended into the objective phase space method?
Is she on there?
So yes, the satellite imagery is, the satellite can be used to determine kind of the symmetry of the cyclone, because that helps kind of help us dictate whether it's a tropical cyclone or extratropical cyclone. And then ultimately, because with the use of the satellite imagery, we can associate that with the warm and or cold core system to use those two together, and then ultimately use them together and see if it is associated with extratropical transition.
Excellent. Are there questions or feedback from the group? There's support in the chat. Excellent job. Anna, do you want to say a little bit about what you're doing next?
Sure. So after I graduate in May, I have an internship this summer working with atmospheric science and research. And then I will be attending grad school at Florida State University, working in tropical meteorology and kind of continuing that interest in tropical meteorology. So that's the pathway for now, but I'm excited to graduate and move more into the future. So
well done. Thank you so much for your presentation. It was excellent.
Thank you.
I will ask our next presenter to get ready. Noah Wolfe will be presenting using inductive generalization principles in the mathematics classroom. So welcome, Noah.
Thank you. All right. Can everybody see that?
Yep.
All right, perfect.
Looks good.
Cool. All right. So, good afternoon, everyone. Like Kyla said, my name is Noah Wolfe, and today I'll be presenting on using inductive generalization principles in the mathematics classroom. And my mentor is Dr. Chris Lawson, who I've been researching for the past 4 years. So it's kind of bittersweet that this is kind of the end of the 4 years together, but ended on a good note. So a little bit background about our research lab. We're a cognitive development research group, and we have been focusing on kind of how students and how school-age children make inductive generalizations. And so an inductive generalization is something every human does every day. And it's anytime you take information or evidence and you make a new conclusion based off of that evidence. So for example, if I tell you that, all the SERA students are really talented researchers, you may be able to generalize that means, next year's SERA students are going to be talented, or every undergraduate researcher is talented. And so we're always making generalizations. And we're specifically focused on what influences those generalizations. So we have focused on the diversity of evidence. So if the evidence is more diverse, do students make stronger generalizations? Sample size, if I give you more evidence. And we also have focused on the spatial location. So if the evidence is actually spaced out differently, would that, differentiate how students, how school-aged children kind of make those generalizations? So this slide, pretty much sums up what I just discussed, but we typically use animals in our research. And so why that's important is because this year, as a student teacher and graduating in just a short month with a degree in K-12 special education, I kind of went into my SERA research year trying to focus on mathematics and if I can use these skills in the classroom. And I'll talk a little bit more about that in a few slides. But this research is typically done with animals. So for example, if, an eagle, a penguin, and a hawk all share a characteristic, could you generalize that another kind of bird has that same characteristic? And so we specifically examine the effects of the diversity principle and sample size. And so these are two examples that I like to use when kind of talking about the research. And so since I'm a teacher, I love to get people interactive. So if you guys want to put in the chat your answers, you're more than welcome to, or just listening. But the first example is about green coffee. So imagine if someone came to you and they said there's a huge ship with green coffee being shipped overseas, and you were tasked with determining the quality of all of the coffee on the ship. Would it be more beneficial for you to take a sample from a bag in the front of the ship, the middle of the ship, or the back of the ship? Or would it be more beneficial to you to take a sample from 3 bags right next to each other? And so most people would probably answer it would be more beneficial to take from the front, the middle, and the back, because that's a more diverse sample of evidence, which means you can make a stronger inductive generalization about the overall quality of the ship. So that's an example of how diversity affects our reasoning skills. The other example I like to use a lot is pizza. And so this one is a little bit more about sample size. If I told you that only one pizza shop in Milwaukee had, excellent pizza, you probably wouldn't generalize that the whole city has excellent pizza options. But if I told you the name of 10 restaurants that all served great pizza, in Milwaukee, it would be much easier for you to generalize about the overall quality of the pizza in, Milwaukee or any city. And so that's an effect that sample size has on your inductive generalizations. The more samples you have, typically, the stronger your generalizations can be. So like I said, I was kind of interested in connecting previous research I've done the last 3 years to math. How many of you guys have ever heard maybe your kid, or if you remember being in math, how many of you remember hearing like someone say, when am I ever going to use math? Why would I ever need to learn this? I hear my math students say that to me almost every day. And the typical answer is, well, you might need to use the formula to find the volume of a cylinder one day, or you might need to know the square root of 25 one day. But really the true answer to that question, I believe, is mathematics, although helpful in a lot of jobs, is also incredibly helpful for just problem solving and and making inductive reasoning. And the Common Core state standards actually state that students should be able to construct viable arguments and critique the reasoning of others. And so that's when I saw that, I was like, all right, how can we use this idea that we've been researching in the mathematics classroom? And I came across this idea called the inductive method of teaching, which basically, instead of the teacher kind of telling students the rule for mathematics or any subject, the students have to figure out the rule through making an inductive generalization and looking at examples. And so here's an example that I've actually used with my students just as recently as a few weeks ago, learning division. And you can see that there are 3 examples of 2-digit numbers being divided by 10. And so if I put this up on the screen, I would ask students, what pattern do you see? And so some of my students said, well, every time you divide by 10, the number gets smaller, which is great. And then another student said, every time you divide by 10, the place value loses the 0. The 10's place value number is now the 1's place value number. And then we concluded, we generalized on a pattern. And then we decided, well, would that generalization work for 20 divided by 10? And when it worked, we made an inductive generalization and concluded on what the rule is for dividing by 10. And so this is kind of a interesting way of teaching, because typically we think of teaching as the teacher shares info, the students memorize it, and then they show that they've learned it somehow. But this form of teaching is the opposite. This allows students to make inductive generalizations about the mathematics, and hopefully, that allows the mathematics to stick and they're practicing those reasoning skills. So my current research focuses on using previous psychological principles, so the diversity principle, sample size, and using that in the mathematics classroom by using the inductive method of teaching. So kind of unlike everyone else, but I actually didn't get a chance to do this actual research in the classroom because obviously of the pandemic. But the research, what I have done this year is I've kind of created this educator toolkit to be utilized in mathematics education, almost a curricular approach. And the reason why, I don't have a final decision on whether we're going to use diversity or sample size, is because as educators know, if you are one or if you know one, your students' needs dictate what you're going to focus on. So if I'm in a school and the students really need to focus on X, issue, then that research will be centered around that because we want students to learn, and we also are interested in these examples. So how does this actually look in the classroom? So here's an example of diversity. So if I was teaching you how to add fractions, on the left, you see 3 examples that are pretty homogeneous. The numerator is all 1, and the denominator is all the same. And if I asked you to make a generalization about this, you may say, or a student may say, oh, anytime you add fractions, your numerator is going to be 2. But if you look at the example on the right, those examples, those are more diverse. We have different numerators and we have different answers. And so the student, it may be easier for the student to say, oh, you add the numerator and you keep the denominator the same. And so this is kind of how I'm envisioning this study to work out in the classroom. Does the diversity of the examples affect those learning outcomes and mathematics achievement? Here's an example of how sample size could be influenced in the classroom. So if I just told you 2, 1/4 plus 1/4 equals 2/4, and 1/3 plus 1/3 equals 2/3, that's really not enough evidence to make a generalization about how to add fractions. But if I give you 5 examples off to the left or off to the right, then it's probably going to be easier for you or the student to make a concrete generalization regarding adding fractions in the classroom. And so we're interested to see if our research from the past 3 years can be used in the mathematics classroom. And so to kind of sum things up, this is just kind of an approach to increasing mathematic growth and reasoning skills. Obviously, we want our students to grow mathematically, and we want them to have strong reasoning skills as they go through high school and post-secondary education. Educators are always asking how we can help students learn and how can we increase reasoning skills, especially in the field of special education. And then finally, like I mentioned, the research is in progress, and I'm hoping to continue it next year at UW Milwaukee as my master's thesis project. So I will stop sharing my screen, and if anyone has any questions, I'd be happy to answer them.
Thank you so much, Noah. We'll open the floor for questions or comments. There's a hand. Sophia, go ahead.
So how exactly, I don't know if you would know this yet, but how do you test the effectiveness of using the diversity method versus the other method? How would you go about actually testing that?
Yeah, so kind of like I mentioned, it's, when we're working with students, we have to be careful because the students' needs dictate what we're going to do in the classroom. So, that's why we haven't made a final decision on whether we're going to use diversity or sample size. But our initial ideas are a post-test versus a pre-test. But we're also interested in looking in, does this help students? If I use adding fractions as an example, would that help students when we get to subtracting fractions? So we're interested kind of in that approach. We're also interested in, does it just increase students' creativity? So we haven't necessarily finalized how we're going to measure that yet. But like I mentioned, hopefully next year working on the master's thesis and working, actually in a school or, having actual students that we can go work with, we'll know what their specific needs are, and it'll be a little bit easier to make a generalization, no pun intended, on what to do in the classroom.
Lots of accolades in the chat, Noah. Nice job, great work. Examples made it easy to understand. And there is a question here. Is this methodology currently being applied to school systems or not yet?
Yeah, so the inductive method of teaching is something that teachers utilize, but it's also something that I personally feel and that research feels that is being underutilized. And so kind of like I mentioned, a lot of your school experiences, everyone went through school, is probably the teacher telling you information, you are expected to memorize it, and then show your knowledge on a test of some sort. The inductive method does take longer. It allows students to make their own generalizations, which means that they may make a wrong generalization, right? And so it's a little bit more difficult to do, but it is happening. But I definitely wouldn't say it's the norm in mathematics education or education just yet. Hopefully one day.
Thank you. And Amanda asks, do you expect to apply this to subject areas outside of mathematics, or is your focus going to be within math specifically?
Yeah, that's a great question. So the inductive method of teaching can be utilized in any subject. It's mathematics. Personally, I focused on mathematics because that's what I teach the most this year. And I often feel like a lot of students have the most disinterest in mathematics. Every time you walk into math class, it's always like, oh, we're doing this today, or, oh, we have to, take more notes, or, whatever, take a test. And so for me, I was like, how can we make mathematics more engaging, more interested? And also, how can we help students the most in mathematics? Because I just feel like there's such an overall level of disengagement. So it can be done in other areas. My focus for the research is math specifically, but I think it'd be interesting to see how this works maybe in a literature or social studies or science context as well.
Thank you. I'll ask a question, Noah. You've been with your mentor for 4 years. Can you say a little bit about that experience and how it's progressed year over year, and how your understanding perhaps has evolved?
Yeah, I mean, I think it's first I know Dr. Lawson is here, so I just wanted to say hi to him and thank you for being my mentor for 4 years. Someone once told me that I don't think there's been someone in the School of Ed that stayed with the same mentor for 4 years. So it was good to get all 4 years in. But Dr. Lawson really threw me into the research lab my freshman year. And, I just got like a memory on my phone that we were down in Chicago presenting my sophomore year. And so he kind of threw me in, and I was helping graduate students right away and writing abstracts. And so it's just, throughout the years, I've progressed into doing more work independently. And then this year it was, he guided me through it, but he really told me that this research was up to me and he would help me. And so frustrating at times when you kind of are stuck, but those are the opportunities where you really get to problem solve, and which has been really awesome. So just an overall great experience.
Wonderful. And yes, thank you, Chris. And in my intro comments to our whole session today, I thanked mentors, but I know mentors have been coming and going. So we, of course, appreciate all the mentor involvement with the students. So thank you, Noah. Wonderful job. And we will move to our final presentation of the colloquium is Paul Newcomb. Paul will be presenting community archiving and safety concerns in documenting social activism. So Paul, you can go ahead, and when we have guests joining by phone, we will hear that, but otherwise we'll keep moving. And Paul, are you here? There you are.
Yep. Okay, can we see that? Can you hear me?
I can hear you, and we can see it partially. I don't know if we can see the whole screen.
How about now?
I see the S and then and concerns of safe. So maybe if it,
Okay, here.
you can reduce size, possibly.
How about now?
Perfect.
Okay, good
Looks
to
great.
go?
Yep, good to go.
Okay. Okay, so I want to start off describing the scope of our project. This project began at the end of May 2020. And so it initially began as a collaborative project between faculty and students at UWM and Marquette University. And it was a fusion between archival work and activism. In the beginning of this project, we were noticing discrepancies in how the media was reporting on marches and protests surrounding the police murder of George Floyd, the protests in Milwaukee, that is. So as many of us were on the ground at many protests, as well as students and scholars with various familiarities with archives and social movements in Milwaukee, we decided that we wanted to begin to archive the ongoing movement to both capture the history of the movement that we were seeing on the ground, as well as documenting the stories being told by activists, community members, politicians, Milwaukee businesses, and the Milwaukee Police Department. So ultimately, we collected several hundred news articles, photographs of street art and protests, statements from Milwaukee Police Department and the politicians, and other information that was posted on social media or was present at protests. And I will note that at the time when we were beginning this project, we were frantically collecting what we could, as many of us were in attendance at a lot of the protests, and we were involved in a variety of ways. But then it was later on in the summer and fall, and now in the spring even, when we began to consider more questions about archival processes and documenting ongoing movements. So I wanted to share a few maps that we worked on in the fall. This is one that we used GIS software. It was just available online. It was Mapbox. And so in this image and in the following image, we extracted data from Facebook events and compiled them into a document, and then input the address data into the software, and it gave us this map back highlighting central areas of where protests began. One thing that we still haven't really figured out how to do with the GIS software very well is is there a way to track the movement? It's harder to do that. Like with this map and the following one, it's only marking where they began. So it's not marking like the route they would take. And that's because protests are hard to know the route that they take, because protests are alive and they respond adaptively to what's happening in the moment. And so in this next one, it's showing, concentrations in the state of Wisconsin. And one thing that was interesting about this movement was, while it is definitely common that, it's concentrated in urban areas, we also saw that a lot was happening in northern Wisconsin too, which was interesting to see. And so these next two slides are just some of the photos that we collected. The first one is from an article, but the bottom one is just on a sidewalk, and then these two were also just tagged on the sidewalk. So street art and graffiti were two examples of things that we were documenting more freely without being like totally concerned about the ethics and safety of people involved in it. So with that, I want to move on to the ethics of care and archival research, and describing the evolution of our approach in archiving. So I wanted to start with this quote from this article from Human Rights to Feminist Ethics, Radical Empathy in the Archives. So this quote encapsulates the evolution of how we framed our thinking about archives while working on this project. The quote states, "What if we began to see archivists not only as guardians of the authenticity of the records in their collections, but also as centerpieces in an ever-changing web of responsibility, which they are connected to as record creators, as to the records creators, the record subjects, and the records users, and large communities. What happens when we scratch beneath the surface of the veneer of detached professionalism and start to think about record keepers and archivists as caregivers bound to records creators, subjects, users, and communities through a web of mutual responsibility?" After we read this piece, we began to delve more deeper into the ethics of care, as they describe it, and how we could protect those involved in the movement while simultaneously documenting the history of the evolving movement. So this marked a shift in our thinking from documenting a moment in history as fast as we could while it was happening, to examining, re-examining, and re-examining again best practices for protecting identities of those who were on the ground protesting. And so this question was particularly relevant when we were considering how to document live streams. And so the thing that we noticed about this moment and recent moments in social activism is like the role social media plays, and the role live streams in particular were playing. Live streams were displaying the first person perspectives and real-time reflections of protest marches and encounters with police and police brutality and what was going on at these protests. And so while live streams were vital in disseminating these firsthand visual encounters with protests, documenting them was problematic because we were asking, was it okay to document them? Even if we did receive permission from the person who live streamed it, it became murky because we were unsure about the legality of when something is uploaded to Facebook, like, does the owner own it or does Facebook own it? And then more importantly, it wasn't just a question of like legally documenting live streams, it also became a question of, would it be ethical to document something like that? And we were wondering that because in these live streams, you could potentially have hundreds of people walk by and, you can't identify all of them and there's no like conceivable way to receive like an okay from all the people who were visible in them. And then on top of that, there were also concerns about if we collect all these live streams and put them in one place, does that mean that it's more readily accessible to police? So ultimately we decided it was not ethical. And we believe that this was aligning with the ethics of care that I spoke about. So then our project has evolved even further. And so one piece of writing that has proved to be transformational in understanding, archiving, and researching social justice movements is this Tuck and Yang piece, Refusing Research, where they ask 3 questions. Why does academe collect narratives of pain? What knowledges does academe deserve? And how do we understand the researchers and research relationships to knowledge circulated and recirculated by the academy? These are important questions for us to consider as a group conducting research about the Black Lives Matter movement. And one thing that stood out in particular about this paper was the discussion surrounding the question, what does academe deserve? And so Tuck and Yang say that academe has, quote, stockpiles examples of injustice, yet will not make explicit a commitment to social justice. And so I think this is really relevant. Many students and faculty participate in research like this. In other words, stockpiling examples of injustice like racism or colonialism, while universities as institutions have not made any explicit commitments to restorative justice in light of past controversies. Universities across the United States as a whole have consistently been resistant to truly rectifying issues of racism, xenophobia, anti-Semitism, and so many other isms on campuses. And my own question that I have asked myself frequently is it okay to do social science research documenting the Black Lives Matter movement when our university invests millions of dollars into campus police forces while simultaneously defunding programs that benefit Black students, immigrant students, Native students, and students of color on campus? How does social science research benefit the university? And I'm still navigating these questions myself, but I think an answer to it, and really a prerequisite for not just doing this research, but as a student of the university as well as a resident of the city of Milwaukee, it's required to be involved in the work meaning anti-racist organizing efforts in Milwaukee. And so with that being said, I want to end with that our archival project work continues into the summer, where we are continuing to engage with community activists in Milwaukee and Kenosha, and are continuing to participate in on-the-ground organizing work. I also want to reiterate that I'm still thinking through a lot of these questions, and I want these questions that this project has raised to serve as a point of discussion between student researchers in the humanities, and especially those interested in library science and archives. And with that, I will end there, and I will open it up for any questions.
Thank you so much, Paul. It's important work, and I think you raise very important questions, and I appreciate your framing in terms of still thinking through and working through them. Questions or comments for Paul? Rachel, go ahead.
Thanks, Paul. That was really nice. That was great. I love the phrase, what the Academy deserves. I think that's a really unique way of thinking about archiving. Can you say a little more about that?
Yeah, that piece, I'm not sure if we discussed it as a group, but that piece was really interesting because it was talking about, yeah, what does the academe deserve? And so they were raising that question because in the past, academe has proved that it hasn't been ethical. And so past examples would be like Henrietta Lacks, or there was a more recent example with a tribe in the Western states. And so, like, I'm still thinking through it. And I guess I am more interested in what other people think too. Yeah, I'm gonna have to get back to you on it because I don't know. I think it's interesting, an interesting question, and it's like I want to hear more conversation about it because I don't know. I don't know, what does academia deserve. That's what I want to know.
I feel like a similar question might be, how have you thus far incorporated some of these thoughts and deliberations into your own practice of archiving some of the elements of Black Lives Matter? You know, is there a point where, you know, what has been that point of stopping to maybe protect identities, and what have you gone ahead and used or archived?
Yeah, I think there would be. I guess it depends on what you know, a particular individual would say. Like, if it's an interview, like you have to be receptive to they're willing to share. But I would also say that it would fall in line with the like previous decisions we've made regarding live stream photographs. Just really not even like bothering to collect those because of a fear that we could potentially harm somebody by having a collection of photographs of people that are currently involved with this. We don't want to somehow aid in police efforts to locate protesters. And while I would say that a lot of the photographs and live streams that are already available on social media are already available to law enforcement, our concerns in that was that we didn't want to make it even more easier or like put them all in one place and have like a bunch of information available about that. So in that, to respond to the question, I think that would be an example of something where academe is not worthy of that knowledge, of that information. And then I saw somebody asked a question.
Yep, Amanda asks, Is there a space on campus, whether this is with staff, faculty, or students, where you feel this research could help affect change at UWM?
Another good question. I'm not sure. I'm not sure that I would know like specifically I don't know that much about the institution of UWM and like which place would help affect change at UWM. I know that it would be great for faculty, students, and researchers, just anyone in general would be more supportive of ongoing movements on campus to defund police on campus and reallocate funding to services on campus that benefit Black students, Indigenous students, immigrant students. There are several campaigns ongoing right now. There is one group, LIT, that is doing a campaign, and then there's another student org called Students of a Democratic Society. So I would recommend getting in touch with those orgs and supporting their efforts, because I feel that a lot of the change that would need to be happening at UWM as an institution would need to really be led by students who are like primarily affected by a lot of these things that are happening.
Thank you. Other questions for Paul?
Yeah, I have a question for Paul.
Go ahead.
And I know we're like a few minutes over already, so I don't want to like provoke a really long answer here. But in an ideal world, this kind of piggybacks off the last question. In an ideal world, how would you like your findings to impact upcoming protests over the recent murders of Dante White and Adam Toledo?
Good question. I think that this should really help with future people who are like thinking about doing work like this. I think it's important to ask a lot of these questions before you even get started. So I guess one thing that would be good is if you are moving forward and thinking about doing research on these issues, is to ask these questions before you get started. Unlike us, when we were just researching and doing all this stuff without asking these questions, because we were in like a frantic, like, oh, we got to do this, we got to do that, we got to document this. It would be good to have these questions asked and raised before you start researching, instead of you do all of this work and then after you start evaluating and asking like, oh, is this ethical? Oh, is this okay? Like, is this something that we should even be doing at the university? Is this acceptable? What are the implications? I think that is something that I've learned and will take with me in future projects.
Cool, that's an awesome answer.
Nicely done, Paul, and thank you very much for your work, and thank you to all the presenters today. These are truly some of the best at UWM in terms of undergraduate research students, and I'm sure our audience has seen that their engagement and their professionalism and passion and curiosity, I think, has been very evident. So thank you all. You did an amazing job. I want to also thank our judges, Amanda Soika and Liz Baumgartner. Thank you so much for being here and listening and engaging. Thank you very much to our research mentors. Of course, your willingness to bring these students into your labs, into your research activity makes all the difference. And we thank you so much for enabling their growth. So we appreciate that. And then to the students, you did a wonderful job, and you all acknowledged the support you have gotten, and thank you so much for that. It really is an honor and a privilege to be a part of your journey as well. Um, so thank you. You're inspiring, and I think definitely inspiring our next wave of undergraduate research students here on campus. I also want to just note that the presentation, so we recorded today, and we will be putting the presentations on the Symposium web platform. So you can continue to engage and interact with the students, ask questions, put some discussion in the comments, or share their page that has the abstract, and it will have the recording by Monday, if not sooner, with the timestamp for where their presentation begins. So we can continue sharing the amazing work that they've been doing, and asking questions and engaging. So thank you. There are some really great words of support in the chat. Nay says, excellent job, everyone. Your work is definitely commendable. Thank you for your efforts to bring social and environmental changes and improvements. Dean Gronert, thank you so much for being here too. And he says, great job, everyone. Yes, thank you all for your work, and it really is heartening to know that you are going to be our scientists and thinkers and writers and researchers moving ahead, and we are so proud of you, and we can't wait to see what is next for all of you. So thank you so much for your work, and you really do make us all proud here at UWM. And Amanda says, thank you too. Amazing job, everyone. It's incredible to see what you all have accomplished. I will agree with that. Excellent job. Thumbs up. Getting the thumbs up from Grandpa, right? Which is the best. So I will adjourn our colloquium for today. Thank you again, students. Amazing job. You all really did a wonderful job, and made us all so proud. And congratulations on your upcoming graduation. So all of our students are graduating this May, and we are so excited to see where you go. So please keep us posted, keep in touch, and we will talk with you again soon. And take a look at the rest of the Symposium website. I will jot it in the chat where you can interact with. We've got about over 250 students presenting, and many are asynchronous presentations, so our guests can interact with those as well. All right, thank you, everyone. Have a wonderful weekend. Great job, students.